Hello, welcome. Have you ever shouted across a very large hall and after a few seconds you heard your own voice return again to you? You see, that magical reply of your own voice back to you is a phenomenon in physics. It is called echo. What then is an echo? How does an echo form? What are the factors affecting echo? How do I apply echo? How do I even solve questions involving echo in my JAM and SSE exams? Interested in learning? Follow me, let's go. What is an echo? I said an echo is the reflection of sound from the hard surface back to the listener, allowing the original sound to be heard again. So an echo is the reflection of sound. You see, sound is a mechanical wave. By mechanical wave, I mean wave that require a material medium for its propagation, either the medium of air or water or probably a solid. And that's why if you are in a vehicle and then you wind up such that air cannot come in and cannot go out, no matter how you shout, the man outside the car is not going to hear your sound, it's not going to hear your voice. He might see your lips moving but can't hear the sound. Why? There is no medium, there is no air to carry your sound to him. Until you wind down such that air can come in and can go out, then he's going to hear you very well. So when sound is released, sound travels until it hits a flat, smooth surface. Now, upon hitting that surface, there's going to be a reflection of the sound. Okay, so some of the sound energy is going to bounce back and return again to the listener and will be heard again. Now, that sound that is heard again is what we call echo. So that's how echo is formed. Now, what are the factors that affect echo? Number one is the distance. You see, the farther the distance, the longer the sound is going to travel. And the longer the distance, the more distinct the echo is going to be. Now, secondly, here is the nature of the reflecting surface. You see, hard, smooth surfaces reflect sound more efficiently than soft, rough surfaces, and therefore produces a much more distinct echo. And lastly, here we have the medium. You see, sound is strongest in solids and then least in air. Okay, now let's move on. We have the applications of echo. Number one, here we have the sonar. That's the sound navigation and ranging. You see, ships send sound deep into the ocean and seas, and then they measure the time it will take for the echo to return again. Now, the time it's going to take for the echo to return is used to measure the depths of seabed and also to locate objects inside the sea. Now, secondly, the area of medicine, in medical ultrasound, so it uses high frequency sound wave and echo from organs to produce images of the body. Now, let's take a calculation here. We have that the person stands in front of a large wall and claps his hands. He hears the echo 0.5 second sounds after clapping. Calculate the distance. Now we are given the speed of sound in air to be 343 meter per second. Now first thing first, like I said, you bring out your parameters. We are given the time 0.5 seconds. Now the distance is what we don't know. Now we are given the speed, that's the velocity, to be 343 meter per second. Now how do we solve this question? So let's move on. But I know, please pay attention to this, I know that my velocity is equal to 2 times distance over time. The speed is 2 times distance over time. Remember, I told you the sound is going to travel and hit a surface and it's going to be reflected and come back. So 2 times the distance. So, but I know that my velocity is what? 343 equal to 2s over 0.5 over 1. So what do I do now? I cross multiply. Okay, such that 2s to times 1, that will give me 2s. So I have 343 times 0.5. How do I get my s? I divide both sides by 2 so that this takes care of this. So s now becomes 343 times 0.5 divided by 2. Why don't you solve this and let me know your answer in the comment section. Bye.